Hello everybody. Today I am actually going to almost go through all the steps of a complete recovery from beginning to end, which is going to take me a lot of time. I might cut out some things. This is ab lib, no rehearsal, so we're going to go on the fly. I already have some things hooked up because I really think most people don't need me to show them how to hook up hoses. So we're going to start from the beginning. This is a 2018 Honda CR-V with the new YF refrigerant. So coming down to your refrigerant identifier, turn on refrigerant identifier, and you're going to wait for the warm-up procedure. Usually I never showed you this in any of my other things because it just takes so damn long. It takes like a minute, and a minute is money. Press OK. Get your stuff ready. Get your package out of your YF adapter, your 134 adapter. Just sit that on there like that, because the next thing it's going to ask you to do is hook up your hose and calibrate. Still warming up. And yes, my gauges are starting to get dirty because I've been busier than ever since this pandemic thing. It's asking you which refrigerant are we going to select. So we're doing 1234, so you hit the button. Ready to calibrate, connect your hose. So here's the hose. Doing this one-handed. Okay, so I just have it sitting here. I don't have it fastened down. I don't have it screwed into the source. What it's going to do is make sure it draws out all air, and it's going to calibrate, making sure there's nothing, it's ready to go. So calibrate. Takes 30 seconds. They really have to do something to speed up this machine. It's too slow. By the extra time it just takes me to take video and everything like that, my paperwork, I should be out of here. And so this is going to take me like 2 or 3 times longer to make video and do this. Okay, calibration note, yes, my filter is clean. Still calibrating. Connect hose to source and open valve. So now I'm going to pull up, connect, screw down to open the source. Now the refrigerant pressure is now going to the machine. Press OK. OK is press. Another 60 seconds. Now for those of you who live in areas where labor rates are still under $100 an hour, we're here $150 to $200 plus an hour. A minute is a lot of time. And if you're in an area of the country where a technician is getting $60 plus an hour, a minute is a lot of time. So while that's doing its thing, I'll explain the setup here. You do not need a set of gauges to do a recovery. Actually, I have a set of hoses too, or just one set of hoses, and then it V's off, going into a high and low to go into the machine. You could totally bypass the gauges. You don't need all this stuff. All you need is one hose with a Y off of it. But I'm showing you here right now, I have my machine is pre-vacuuming out. You can see I'm already into 15 microns. This recovery machine has my hose line set cleaned out to 15, going down into 14 microns right now. You always make sure you're all purged out and clean. And we should be done. 100% YF. It only has like 2.1% air. From the dealer, brand new. Usually you'll always see around 1%, few points, up to 2%. Brand new from the factory, because they do not go through the correct procedures of purging out and doing a long vacuum. At a manufacturer, everything is clean and new. The lines are new. It's supposedly exposure to ambient air with high moisture content is minimum. And so they just kind of like blow through the refrigerant, do everything really fast, and you always come up with 1 or 2% air. from a brand new vehicle, the highest percentage of air I have record to record to date on a brand new vehicle, 3.7% air out of a brand new vehicle off the showroom floor. That's ridiculous. There's no reason for that. Okay, so now we're down in the microns. I have this cracked over here because I purged out all this line here. Turn it back into drawing down. I'm going to get ready. So what I did here on the controls here, so if you were going to take out for fast acceleration, pulling out refrigerant, it's in position A. And then anywhere between A and B, this is for vapor. If you're, straight up you're getting hammered, it explains when liquid hammering occurs, turn acceleration knob to A, adjust main knob from 1 to 0. And so 0 is closed, 1 to 0, so you can actually slow down your recovery by choking it off until you get all the way to close. Push-pull configuration. For you guys who are in the automotive, you don't know what this is, and I'm not even going to bother to explain what this is. This is for guys in commercial HVAC and stuff like that for doing really large systems. Cars are just like a drop of refrigerant compared to a large commercial system. And then there's purge. Purge is when it cleans out the machine and it bypasses and it draws down the condenser and starts pumping out all the refrigerant to get the very last ounce of refrigerant out of the complete system, and literally even pumps down the condenser to get everything out, all of its lines and tubes, and then pushes it forward directly out of the pistons right out the line, and so you get your very last bit. So this is still loose, and I went through recovery and purge, and so now I'm in purge mode. So now I'll close this because we're down into the deep microns of evacuation through all these lines. And since I'm using my camera off my phone right now, I take a picture of this, and this picture of the purity of air is required by the California EPA now, or no, it's the Bureau of Automotive Repair in California. It's mandatory all shops use and have a refrigerant identifier. It's as of 2018, and so I take a picture and this goes into my electronic invoices. I don't have paper invoices no more. I have not used paper in over a decade. I went paperless with all my shops over a decade ago. No invoices, they're all electronic. And so now I can take this off. That was from our identifier. This is not closed yet. This is on the liquid line, and it's past the receiver. So this is filled with liquid, and it has a lot of oil in it, and I don't want to take out the oil, so I will not put this one down. This is on the vapor side suction, and it's at the highest part of the system, so I know any refrigerant is down deep there. Any liquid refrigerant and oil is down deep there, and this will be like, think of an accumulator. So I can come off here. We're still in the deep microns. Had a little bit of pressure built up there because I was still in purge. Dropped back down to 0. So I'm gonna get that again. Okay, so now I'm gonna get it ready to recover. Open up to the tank. Okay, so I'm going to close the valve to gain access to the refrigerant system on the low side only right now. Let's watch our gauge. And I'm starting to turn the knob now. Bingo, there we go. We are now into the system. And as you know, it's even though the system pressure is around 67 psi right now, the quantity and volume of refrigerant being removed and the ability of this machine is really pulling it down here. As you can see, the pressure going into the tank right now, the pressure coming from the system. And I'll also show you, I'll do this for you. It's not pulling from the high side, but I'll show you the high side so you see the difference. So now I'll crank down the high side so you can just see. There is the high side pressure. Here's the low side. I'm drawing out of the low side only right now. I am not drawing out of the high side. There's still a lot of liquid in here. The outside ambient temperature is about 63, 64 degrees right now. So the pressure in this system, this is a crash car. It was sitting here overnight. So the pressure of the refrigerant in the system is nearly the same, if you go to a PT chart, is nearly the same of whatever the temperature of all these lines are. So if you actually took a contact thermometer and you touched all the refrigerant lines, and you see, since this vehicle sat overnight in this location and last night got down to about 51 degrees, and it's only been 60 some degrees in the last few hours, you'll probably find out when I came in here and you actually touched all the refrigerant lines, there were probably about 58 degrees, 57 degrees. So the actual pressure would have been about 58, 57 degrees, close. Use the PTR chip to find out exactly what they would be, because you would have liquid refrigerant in the system. That would have been my starting point. Even though outside might be 64 degrees, the vehicle has not warmed up because it sat here all night. So let's look back at what we're at. We're at negative 18 vacuum on the low side right now. And our high side is in we're finished. Basically, we're considered almost finished. Now here in California, in the EPA, and let me open up the high side now because I'm not going to draw out any oil, because there's no liquid there to draw up and suck the oil out of the system. So now I have both sides on and I'm just hit 15. So the EPA rules here, as of now, written in the law, your new machine, if you had a brand new YF machine with all the latest firmware update and everything like that, you're to draw a vacuum to negative 15 vacuum. And then the machine automatically shuts off. And then you watch to see if the vacuum starts creeping down, say 14, 13, 10. If it's doing that within so many minutes, go read the rule book. Okay, I'm going to make you go do homework. Read the rule book. You shut it off, and if it creeps back up, you turn the recovery unit on again until you can obtain past 15 vacuum. Shut it off again, watch for creep. If it creeps back up, turn the vacuum on again, and you keep repeating this process. Now, if you're somewhere it's winter time and you're not in a heated garage and you can't start the engine for some reason, that's going to take a hell of a long time. It could take, I've had it taking me 40 minutes to do a simple recovery on a cold day. Not with this machine, other machines. And this machine freaking sucks start a Harley. So you have to keep going that procedure. Right now you can see I have this system drawn down to 1100 microns with a refrigerant recovery unit. This is not a vacuum pump. With this refrigerant particular recovery unit, I'm capable of going down to the micron range. So now I'm going to shut off the recovery and close it off, and we are going to read the pressure inside the system. Now, if this was a normal car that I could start, but because this wasn't an accident, as you can see here, this got smashed pretty good, but there's no leaks. All the refrigerant's still in the system. As you can see, it only took, other than me wasting time on video, this thing recovers really fast. Okay, so now I have the recovery off. I have it open to both ports in the system. And you can see the refrigerant is actually bubbling up, and that was that jump. I went from microns to 19 psi. And this will keep creeping because, say way down here in the receiver, where you have liquid trapped down in the bottom of the receiver dryer, and these bottom like 4 or 5 fin tubes were all filled with liquid refrigerant mixed with oil. Some refrigerant is trapped inside the oil, just like a Coca-Cola bottle in your carbonation. You crack the lid on your carbonated water or your carbonated soda, and you release all the pressure. But you put the cap back on your soda and it repressurizes. Same thing is happening here. Back in the evaporator, you have a lot of oil sitting in the bottom rows of the evaporator. Same thing, refrigerant trapped underneath the liquid oil is bubbling out again and flashing. Now you can see here within a minute of me talking, since I turned off the recovery, we've dropped to, we're going down into the 16 inches negative of mercury vacuum, and we're going to creep up. Now I could speed this up a lot if I could start this engine. If before I started this whole procedure on a cold morning on a car sitting on a ride, my normal procedure is to start the engine so I could start heating up the engine, turn on the blower fan so I could get warm air going over the evaporator so it have a load so it could help flash off and boil off the refrigerant. And same, you would have your engine fans going on, taking this warmer 60 some degree air and pulling it across the evaporator, and then you perform your recovery because it will speed it up and make it more thorough, and it would end faster. Now you see here I'm approaching 15, and a couple more minutes it'll actually go down to 14. So that means there is a little refrigerant trapped in the system, and you don't want it to be trapped in the system because it would be venting to the atmosphere. That'd be a waste of refrigerant, especially this refrigerant. Since it's $150 a pound, every ounce counts. I might have another half ounce or ounce of refrigerant trapped under frozen oil. If this was a real cold morning, you might even see ice develop right there here in the bottom, like ½ inch of the receiver, or the very bottom tube. You might see a little ice develop as you're doing a recovery. Or this lowest liquid line point, right here at the very lowest point of the liquid line, that's right here. Because this is so low, there'll be some liquid refrigerant right here. You can literally see ice form on this because liquid refrigerant gets trapped in there with underneath the oil, and it freezes up when you draw it down to a low vacuum. So I'm going to open this up again to take the last of the refrigerant out because there's still a little refrigerant left in the system. So let's open it up. And I think one thing I forgot to show you, and I didn't do because I got distracted making a video, was when you're in the vapor mode, for better vapor recovery on this machine, when you're doing it into full vapor, you turn it down to this position, and now it's more geared up for taking vapor refrigerant out. It will work more efficiently. And so as you can see here, we're down to 1200 microns, going into 1100 microns. It works really fast. And like if you've seen any of my other videos, ever since I've gotten this machine, even though this machine was more expensive than all the other machines, in the speed that which I could obtain, and if I do 5, 6, 8 recoveries every day, this thing has made all my money back within the first 2 or 3 weeks. And then now I'm in a positive net gain of profit because I could do more recoveries in a day with this machine than I could have done with any of my other machines. I have 3 machines. I have this one, I have the field piece, and then I had, shit, it's been so long since I even looked at the name because the stickers all fell off. That old black one I have. So I almost barely used the other one. I'm gonna replace all my recovery machines with these machines just because they're so damn fast and they make your money back so fast. If you have a lot, if you're a high volume air conditioning company and time is money, this is the only machine I recommend. Okay, so that's it. We're down to 900 microns under refrigerant recovery. We're done. So that's about the end of this video, other than I'll show you the purge procedure. As you can see, I'm shutting off the high and the low. Closing the recovery. Finishing off there. And you don't need gauges to do a recovery. I wouldn't have to go through all this BS if I wasn't showing you to show you the numbers and everything like that. It would just be this straight hose going to a Y off to 2 gauges, 2 fittings, and that's it. That's simple. No gauges. Gauges are not needed for this because you have your gauges right here. Okay, so we're already in the vapor recovery mode. Now we're going to go down into the purge mode to get the last of the refrigerant out of the condenser and all the tubing in here and push it into the tank. So I'll go into the purge mode, on here. Now I'm in the purge. So now it's cleaning out, because this is already cut off. And so right now it's sucking the last of the refrigerant out of all the tubing and the piping and the condenser. And you watch this drop, the PSI drop here. You turn it into a vapor and get the last liquid, it condenses it, and then that to the last liquid, and then this will go down, and it's pumping that into the tank. As you see the high side of the tank go up a little bit. Now, if you're in a real hot climate, this actually does a real good job even in hotter climates. You drop your tank into cold water. If you have a garden hose and your tank pressure starts going up to 200, 300 PSI, put your tank in a 5-gallon bucket and just dribble a little water over it and let it fill in and displace. Or you can put the hose into the bucket under the tank and then sit your tank under it, turn on the hose a little bit, and the cold water will raise from underneath and come outside of your tank and spill over. Or if you don't have a bucket, you just slowly dribble it over the top and let the water go over. If you want to take that one step further, you put ice cubes in your tank. And if you want to take that even to a further extreme, when you're using high pressure refrigerants like R410, you put dry ice in a 5-gallon bucket and chill down your tank. And you could add water if you want. And that'll lower your high side pressure, making it really easy on the machine and speeding up your recovery by another 30-40%. So when you're on large systems doing 10, 20, 30 pounds, dry ice works really good to speed up. And that few dollars you spend on dry ice are just a fraction of what you make extra that you can charge, because instead of taking 4, 5, 6 hours on a job, you recovered it in 1 hour because you used dry ice. You spent $20 in dry ice, but you charged an extra 2 or 3 hours of labor at $150, $250, $350 an hour, but you cut that down to a fraction of ice because you used dry ice. So we're done. That's it. The system is finished. I can now close this. All the refrigerant is inside the tank. And put this to the closed position. And I don't use switches to turn off and on, because anytime you're putting a load through a switch, you're making an arc on the switch and it wears out the switches. I like to do this. Now, I'm doing this for camera. Stepping on this, that would ruin the cord, but I'd put my hand here and pull it apart. You make the arc here. It's easier to change plugs than it is to change a burnt out contact in your switch. Same goes for your vacuum pumps too. For you guys who use vacuum pumps and have the switches die on you, the switch would never die if you never used it. So the switch goes on, and for the rest of the life I never use the switch on my vacuum pumps, because I've had many vacuum pump switches burn out. So what I do is I connect and disconnect here, and your switches last forever. That's it on this video, guys. And as you can see, we're holding a really good vacuum into the mic. Drop the phone. See you guys later.